It's kind of wild to think about, but we spend roughly a third of our entire lives doing exactly one thing. We close our eyes, the world just kind of fades away, and we surrender to the night. But what's actually happening during all those hours in the dark? Well, in today's Explainer, we're exploring the vital architecture of sleep and mapping out the incredible night shift that happens right inside your own body.
Okay, let's dive into this by shattering a massive misconception right off the bat. When you finally close your eyes after a long day, it's so tempting to think of sleep as a giant off switch. Like closing the lid on a laptop. But is your brain actually switching off? The answer is a resounding absolute no. Your brain is doing something way more complex than just powering down.
So first up in our explainer, the need for sleep.
To really get it, you gotta think of sleep as a highly specialized pit stop for your core biological systems. Basically, three critical things are happening while you're out cold. First, it reinforces your immune system, which is your body's absolutely crucial defense mechanism. Second, it takes the strain completely off your cardiovascular system, giving your heart a much-needed break. And third, it regulates your metabolism. So this isn't just passive resting, right? This is an active, systemic maintenance period that literally keeps your engine running.
But hey, the maintenance isn't just happening from the neck down. Up in your head, there is a serious cleanup crew getting to work. While your body is busy being repaired, your brain is actively clearing out all the daily metabolic waste that builds up while you're awake. And get this, at the exact same time, it purposely lowers its overall energy consumption. It drops the demand for energy so it can completely focus on taking out the trash, so to speak.
Now, what's really interesting about this process is how we literally recharge our chemical batteries. By dropping that overall energy consumption we just talked about, the brain gives itself a chance to replenish a key molecular fuel source called ATP. You can think of ATP as the literal energy currency of your cells. Throughout the day, you're constantly spending it. But during sleep, your brain is actively working to recharge this vital fuel to prepare you for tomorrow.
And honestly, we feel the results of that biological recharging the very moment we wake up. Having adequate sleep is the foundational thing that allows for optimal brain function during the day. We're talking about a significantly improved mood, a much sharper focus, enhanced learning, and way better memory. All of those daytime superpowers? Yeah, they depend entirely on the maintenance done during the night shift.
Which brings us to part 2, the brain's night shift.
So the crucial point here is understanding what the brain is actually doing behind those closed eyes. Instead of interacting with the busy outside world, it turns all its attention inward. It's working incredibly hard to consolidate the memories from your day. Literally every conversation you had, every new skill you practiced, your brain is actively locking all of that into long-term storage.
And this brilliantly illustrates how your neurons completely switch states. In your waking state, their primary job is helping you navigate the daytime world and process everything happening around you. But in the sleeping state, it's like the software completely changes its operating mode. They shift entirely to processing complex emotional information and replaying your own internal thoughts.
Now, you might be wondering, wait a second, if my brain is doing all this heavy lifting and processing, how is it actually resting? Well, it's precisely this shift in nighttime mental processing that does the trick. By handling entirely different internal signals, your nervous system finally gets to take a break from the constant barrage of waking stimuli. That shift is exactly what allows your nervous system the profound rest it so desperately needs.
And that leads us perfectly into part 3, the science of dreams. We've all experienced them, but what are they, really? Well, dreams mainly occur during REM sleep, which stands for rapid eye movement. Think of this stage as the absolute prime real estate for dreaming. During REM sleep, the brain is incredibly, highly active. In fact, brainwave activity during REM can look remarkably similar to when you are wide awake. It's this intensely high level of activity that drives the vivid, sometimes crazy experiences we call dreams. Let's see how this builds. Imagine your brain acting as a master storyteller. Step 1, REM sleep triggers that incredibly high brain activity we just mentioned. Step 2, this activity produces essentially random neural signals firing off all throughout the brain. And step 3, that's where the magic happens. Because your brain naturally craves a narrative, it stitches those random signals together to make sense of them, creating the bizarre, wonderful movies we watch in our sleep.
Now, admittedly, scientists are still unlocking the exact, definitive purpose behind all of this, but it is super clear that dreams play a huge role in processing our deepest emotions and memories. The narratives your brain creates are fundamentally connected to your accumulated experiences. It's essentially an emotional sorting mechanism, and it's happening entirely in your subconscious.
Which leaves us with a truly fascinating thought to wrap up on. The next time your head hits the pillow, I challenge you to think differently about what's about to happen. You aren't just powering down for the night. You are literally clocking in for the night shift. Your immune system is gearing up, your brain is clearing out the day's waste, it's recharging its ATP batteries, consolidating your entire waking life, and preparing to weave a bunch of random signals into a vivid, emotional narrative. So, as you drift off tonight, I want you to ask yourself, what story is your brain gonna tell tonight?